Are we on? Yes, we're on. Cool. Okay, great. Awesome. So let's get started. So thank you guys for coming. And I know that F1 didn't make your lives any easier. And so thank you, Max Verstappen, for screwing up the transit here. Again, if you guys haven't yet, please register. We want to be in touch with all of you. I'm going to do a little bit of an intro for Midnight. Midnight is a partner chain on Cardano. If you don't know what a partner chain is not a layer 2. It's not rolling up into Cardano. It's also not a parachain because we don't need to lock up any tokens in an auction. So it runs based on the same set of validators as Cardano. So it inherits Cardano's security. So block producers on Cardano can register to become Midnight block producers and therefore secure the network. Midnight runs on a very different stack than Cardano. Diego here is going to walk you through what it looks like to develop an application and a smart contract on Cardano, on Midnight. It's much different, and it's a partner chain that is aimed at data protection. So the goal here is to use zero-knowledge proofs to build better applications that secure your users' data and the company data that they're interacting with. I'm going to give you a little spiel on why Midnight, first and foremost. This is a funny illustration I like to use. That bucket is the internet. The water is our data, and our data is leaking everywhere, right? If you've been in the internet at any point in the last 20, 30 years, you bet that your data has been leaking around and people are doing better use of your data than you yourself. We learned that giving away our data gives us free access, free here on quotes, to not so great big data, big tech applications. So we got used to this, right? This is a classic slide of how much data gets produced at every minute in the age of the internet. And this is all data that you and I and every one of us are producing and getting manipulated elsewhere, right? Staggering numbers. We're increasingly more connected. Everything now is connected. Devices, there are devices talking to each other. There are devices paying each other. With the introduction of AI agents everywhere, we're going to see that number skyrocket even more. And in the internet, this is all open. Right? The data that's being sent across the internet in data packets is visible to everyone. We can see everything, and every piece of data can be hijacked and monetized by anyone. Right? So we're sharing more information than we need to. We're sharing sensitive and valuable data. We are at risk of identity fraud, and we don't have really equity in the use of our own data. We can't monetize it as big companies can. But the companies are not just monetizing data. They also have high cost of compliance because they're storing data from everybody. They have to govern that data and maintain that data. And because they accumulate so much data, they accumulate a lot of value. And they become honeypots for hackers. So they're not as secure as we think they are. So for us in Midnight, we think that data has to provide utility. But it cannot be to the expense of sensitive data or access to sensitive data. So if you're a retailer, cost, price, volumes are very sensitive. They're very strategic. And if you put that on the blockchain, well, everybody's going to know, right? But we introduced blockchain. We're reclaiming our data. Remember, read, write, own. Let's put in the blockchain, because the blockchain is the internet of ownership, right? My friend Leo here, if you guys don't know him. Blockchains are great. They're decentralized. They provide self-custody. They're censorship resistant. But they're also very transparent, right? Once you're in the blockchain, well, you're immutable. Remember that? You're public. Now, data about your data can be collected, can be correlated. And if you try to go all the way into privacy, in privacy chains, regulators don't really like that. So How do we solve for that in the world of blockchain? Well, we invented decentralized apps, the famous dApps, right? You have users sending data over the internet. That data sits on blocks on the blockchain. It's readable by whoever has access to that blockchain. And now we're recording metadata into an immutable database over time. Companies still have access to your data, but now everything is in blocks, one after the other. We create public metadata, and now we don't veer off from storing sensitive data. Companies still collect sensitive data in a different organized fashion. If you've ever seen any of this, explorers of the world, right? You have access. If you can find the identity of a pseudonymous address, you have the whole history of that address. Who they sent data to, who they received data from, maybe who they are, what tokens they're storing, what type of bags they're carrying. And at some point, this becomes either dangerous or embarrassing. Hopefully more embarrassing than dangerous, but still not great, not a great experience, right? So you say, well, then companies, what they're doing? Well, all of these companies here, this is a little bit old of a slide, but all of these companies here are implementing some form of blockchain in their businesses. And they're doing that with your data, with their data, data from their suppliers, data from their customers. So this is becoming increasingly more ubiquitous, which is great for crypto, right? It's great. More blockchain is better. But how about the data? So they're increasingly becoming more and more honeypots. So they're storing data. Now we have correlatable metadata. This is all examples of metadata, right? Sender address, receiver, a timestamp, transaction amounts, fees, how much you pay for a transaction. How many times have you seen I can't say X, it's Twitter. How many times you've seen on Twitter people are making jokes of, oh, so-and-so paid $3 million in fees for a transaction that moved like 5,000. It's ridicule, right? It's all in the open. Smart contract interactions are also public, and all the data that goes with them are also public. What that creates is that it now allows for inference. You can actually derive information that is very relevant from the metadata. Things that companies find useful or are sensitive are production throughput, how much they're putting out in terms of industrial production, how frequent they ship that thing, how much carbon are they offsetting or producing. These are all sensitive information, including for enterprises. So when we think about Midnight, we want to introduce data protecting dApps, still on the blockchain, still running on a decentralized, censorship-resistant, self-custodial way, but now with private data. So when you build for Midnight, when you build data protecting dApps, what you do is you introduce the concept of private data being stored at the user end, and then proofs about that data moving onto the blockchain. So you're moving proofs, not data. What that allows you to do is to provide on the blockchain, shield the data when you need to, because the data is shielded from the public and from whatever company might have access to that blockchain, but you can also provide unshielded data if you need to. Public data, still the same. But now you have a choice. In the case of providing unshielded data, you can protect metadata, because that metadata won't be visible to everyone. And then the companies there will be able to see the updated state of a smart contract, but they don't need to collect the data. They will only have access to proofs. So imagine a business that instead of running in egregious amount of data, all they have are proofs to carry on their businesses. The risk and the cost of securing that data are now, the proofs can be much, much smaller. You don't have the same honeypot situation because the proofs are only valid in context. So here are some principles for when we're developing data protecting apps. So the data remains with the owner, meaning it never leaves your device. You can program the shielding or the protection of that data or the proofs, you can selectively disclose the data, shielded or unshielded, and you become compliance friendly because most businesses operate in compliance regulated fields, including data protection. If you've been to Europe, GDPR. If you went to Brazil, there's LGPD. If you're in the US, there's HIPAA and other regulations. So if you're in the blockchain, let's say you're in the blockchain doing a financial transaction as a bank, maybe you're in breach of data secrecy acts. That's not where you want to be, right? There are reasons for that. So we'll stop talking about data, and now we're going to just start talking about proof of data. And if that's enough for businesses and individuals to carry on with their lives, data is protected, business can go on as planned, and everybody's happier. Now, what can you prove and why can you prove it? Proofs can be about anything. It can be about a secret, know your customer, data integrity, system performance, even product. If you're in life science, product formulation is critical. You wouldn't put that data on the blockchain, but you could put a proof about that and interact with your suppliers. So these proofs can definitely resolve some of these problems. So if you're in procurement and you have bias in your process, by looking into the data about the providers, you can remove the bias. You can have sanctions screened without disclosing the identity. You can have safer operations on financial institutions, especially when it comes to risk. You can monetize sensitive data. You can protect intellectual property by having access to a particular set of proofs about that intellectual property without revealing what's behind it. And you can help scale IT and data networks by having a smaller data footprint just by interacting with proofs. So for individuals, the larger benefits is you get control of your data. We're all happy with the Internet of ownership, but now you can actually select what you open up to the world. Rebalance of equitability, meaning if I can have control over my data and access, I can actually charge for it as an individual. It gives me power back because if my data is valuable to others, it should be valuable to me as well. Because you're not transacting data, you're transacting proofs, there's less risk of fraud, and you can actually create your own credentials and move them around because you can be identified by your proofs, not necessarily by your data. Now, companies also have benefits, right? If you're protecting your IP, it's a big plus. Reduce cost of compliance. I mean, this is probably one that even detracts from investing in new products, in R&D and innovation. So if you're more compliant at a better cost, you can innovate more, you can do more blockchain. Reduce the risking of hacks, because hacks will happen, but if all they find is proofs without context, they can't use that for any, evil purposes. And you can unlock data monetization even then as an enterprise because they amass a huge amount of data. They can now do that with proofs. Now, we're going to start here with Diego, but if you want to continue to read about this, we released the night paper yesterday. So this is the QR code that'll take you there. And we have the midnight docs where you can browse everything about the system and learn more about how to create your own applications. We're going to go through a lot of that with Diego. One final word before I'll leave you. Midnight is currently on DevNet. We have now announced testnet starting October 1st. We're in the final preparations to open that into the world. There's a big roadmap ahead of us before mainnet next year. And I hope to see you guys around building on Midnight, breaking Midnight if possible. I would love to see that because then I can go and fix it before mainnet. And we have a very active Discord community where you can ask questions. We have obviously the DevRel teams there, but also some of our engineers and architects are present, and we have a thriving community, and that's where you learn about hackathons and very interesting things coming our way. So I think that was my last piece, and I'll leave you guys with Diego. Thank you so much. And if you guys are back at the venue after the workshop, I'll be at the IOG booth with Emurgo and IO. It's 227 5th floor. Happy to keep chatting with you there. Thank you.
Thank you very much, Mauricio. Yep. I don't know if I'll see you later. Okay. So, no, I don't think. Good. Okay. I think I am. So, let me. Yeah. Okay. And there you go. So I'm going to be covering like 3 different parts of the presentation. So the first one is a little bit like an intro, although a lot of these topics kind of like are overlap with what Mauricio just introduced. Then we're going to have like a really quick use case scenario that is going to give you more of an idea of the kind of things that you can develop with Midnight. And then at the end, we're going to have like a really quick, more like workshop type of scenario where you are going to see how to set up your environment to start working with Midnight, and then create a little bit of a smart contract that we're going to run, that we're going to see how it is, the structure of how you can create smart contracts with Midnight, and a little bit of what goes on there. So let's get started. Just make certain here. Okay, turn. Traditional web applications, this is something quite similar to what Mauricio was just kind of talking about. So right now in Web 2, mostly you're going to have a user who's going to kind of like connect with a resource across the internet, and that resource is going to have access to everything that you are going to have there. So like the content, password, like who you are, and any kind of like information that you're going to be sending around the world. So in general, that's not bad. It has been working for many decades now. So in most cases, like it serves its purpose. We have been making the world run like that for a while, and things are still not falling apart. But clearly, that's not perfect, especially when you already have like several companies that do have almost as a business model using your data. So that's when we begin to kind of like move to Web3, and that is kind of like, I guess, an improvement just from the get-go. Mauricio was already talking about that. You're going to be more decentralized. You are going to be a little bit more open, and obviously you are not going to have like that obfuscation of where the data goes, how it's managed. But what happens when you don't really want to kind of like share all your data? What happens when you do have a good reason to kind of like do that? So right now, most blockchains are not really prepared to kind of like deal with those situations, especially because you have like some real world requirements, like regulation. And then if everything that you put on chain is immutable and is accessible to anyone, then okay, how is it that I'm going to keep some of that data well protected? And of course, that's when we kind of like move to Midnight, and there. Pretty much, this is something that Mauricio was already kind of explaining. Our solution mostly is focused on giving the users and the developers the ability to decide what is going to be shielded and what is going to be unshielded. So when you're going to develop a dApp with Midnight, you literally say like, okay, well, I have this data, and I'm going to figure out in my use case what makes sense to share and what doesn't, that doesn't make sense to share. What is going to be on chain and what is not going to be on chain. Of course, this is one of the situations that, like yesterday, someone was asking me about that. Like, hey, can you go back and forward between what you share and what you don't share? Sure, but it's one of these things that you cannot really unring a bell. You know, if at some point you decide that, hey, I'm going to share this, you cannot unshare it. Like anyone already could have access. But you still could say like, hey, up to a point, this data is shielded, and then after that is unshielded. And like you see that, for example, with classified documents. Most of the time there is like a date when data is going to be available for everyone, and then everyone kind of like benefits from like learning about that. So that's kind of like a good thing. So move to the next cube. I'm presenting everything kind of in forms of cubes here. So let's talk a little bit more about Midnight and Compact, so you can understand a little bit more how we do things. So first thing, mission of Midnight. I think it's quite clear for us that the entire point is to try to make Web3 crypto kind of like go mainstream, make it available for everyone, but at the same time we have to be realistic in terms of the requirements that the industry, the different governments, the different entities kind of like put on us as developers, and we just don't want to kind of like provide something new at the expense of kind of like not giving that freedom to developers and to users to decide what is it that is going to be there. Mauricio already mentioned the entire part of being a partner chain to Cardano. I think from my point of view, one of the most interesting things is that in the long run, a lot of the developments that Cardano and the Cardano ecosystem are going to implement on the chain, we're going to kind of like benefit from that, you know, and like specifically for SPOs, for node producers, we are going to kind of like take advantage of that, and any kind of like a new feature and improvements or, well, bugs that are going to be obviously debugged and destroyed, then we're going to take advantage of that. Apart from that, the last thing that I'm going to say around what is Midnight, of course, we're about data protection, zero knowledge. We have CK snarks, kind of like supporting like our technology back there. Now, this is one thing that I'm not going to get really into this. I think we could spend better time kind of like just sending you to the documentation. There we have like the entire image there and the full explanation in the detail of what it is, but we can just in general like see how things work. So obviously a user is going to have a request, so they are going to retrieve a commitment directly from the Merkle tree, and they are going to take that private data that they have access to, that they can act on, and is going to be able to mix with a new state, generate a proof, and then it's going to submit a transaction that is going to be added later after it's verified the data that you're going to be submitting. Okay, then move here. Now, this is something really important that I'm just going to start talking about Compact. So when you're developing for Midnight, you're going to be using two different programming languages. One is TypeScript, and then the other one is Compact. So most of the development that you're going to do is in TypeScript, and that was a conscious decision that we had. It's funny how sometimes in the Cardano community, even people that have been in Cardano, they still kind of come like, are you developing in Haskell? And it's like, no, like we decided to do it in TypeScript, mostly because of the adoption and the ease that you already have. Most developers have some familiarity with JavaScript. And if you can check the ranks year after year, JavaScript is kind of like almost every single year top one in terms of popularity. So it's really easy for you to just kind of like use that knowledge and start working there. Yeah, I do know TypeScript is not JavaScript, it's a superset, but still most of the knowledge that you have there kind of like is being able to translate. So what about Compact? Well, Compact is a language that we created just for smart contracts. It is quite like TypeScript-like, and we do have a team that is dedicated just to like the creation and maintenance of the language, and we're trying to make it even more TypeScript-like, just to make it easier for everyone to get introduced there. Now, we kind of like made it like just a small section of everything that you need to do for your dApps, just to make certain that you kind of like take advantage of it. And what is the advantage of having something like Compact? Mostly that you don't really need to know a lot about zero knowledge and a lot about, well, circuits and proofs and all that to still kind of like have the benefits that you get with Midnight. So the entire point is like, hey, try to start building as soon as possible, and then learn some of these new concepts at the same time that you are developing. Well, let's take a break. I think we have been kind of like running kind of like late in general, so, and I don't think we have the coffee there, so I'm not going to go for the break. So let me just kind of like jump to the next part. Okay, TicketSquire, yes. So what we wanted to kind of create with TicketSquire, it was a use case that exemplifies a little bit like the kind of things that you want to do. So let's talk about like what is it that we want to do with TicketSquire. So it would be a fictional company that is going to allow you to have a ticketing company, like a marketplace that we're going to use there. So importantly, it's going to be scam-free. That is one of the main hooks that we should have for this platform. And the users should be able to sell, buy, and exchange their tickets. So this is going to be important because then if you want to go to, well, F1, but you cannot attend, then you can take your tickets and kind of like exchange them for, I don't know, Taylor Swift. That's what you want to do. And perhaps there is a difference in cost, so you may pay more or they may pay you more depending on the value of each one of them. Now, that being said, let's talk for a second about like some of the threads that you're going to have in general for an application and then for ticketing systems in particular. So you have some here, these are generic, but some that I would like to kind of like point to right now are data breaches and insider threats. And then the entire thing is that ticketing systems frequently hold sensitive data. You may not think so much about it, but you do. You know, like, and well, that happens in many other contexts too. You are going to just buy an airplane ticket. If you really think about it, sometimes your purchase could be just in the hundreds of dollars if you're going close by city. And still you have to share a lot of your data, a lot of the information that could lead to someone to identify you. And now imagine that you're kind of going to, again, Taylor Swift concert. And the company is hacked. They get a lot of this data and somehow someone now can dox you just because you wanted to have a good time in a concert. You know, so like that really doesn't make sense. Like the risk there is incredibly high compared to what you're really kind of like getting in return, you know? And then you think about it, like a few years ago, was it Sunny that in PS Live, like they lost information about many of their users and, well, people just wanted to play a game, you know? So it is kind of like a huge problem there. Now, one thing that it is just about, like, these are some of the risks specifically just about ticketing platforms, but you could think about similar risks in other contexts. Users could have, well, users or employees could have unauthorized access to information, and then that's something that we have seen many times. Employees getting information about customers, about users, about patients that they shouldn't have to. The same thing in this particular case with ticketing, tampering the tickets. That's something that happens a lot. And of course, sabotage and, well, unreliable partners that you could have there. Requirements. So let's kind of like think for a second about the requirements that you are going to kind of like have for the different actors in our TicketSquire. So first is going to be around the seller requirements. So in this particular case, the seller needs to sell tickets without revealing a lot of information to the buyer or to anyone else that is there participating. The first thing is information about the ticket, so the serial number that could, or well, the barcode that could be released. The same thing about their personal information. So you don't really need to know that Jim, John, or Mary are selling the ticket. The only thing that you really care as a buyer would be the ticket itself, and also the transaction history. It doesn't really matter how many tickets you have sold before. You are just talking about one specific ticket right now. On the other hand, the buyer, they also don't want to share any kind of their personal information, especially when it's identifiable information, you know, and this is really important because it aligns with the regulations in many different places, in many different geographies. Mauricio already mentioned some things around that, the US, GDPR in Europe. And also the buyer doesn't want to share their location or their transaction history. Finally, for TicketSquire, we're going to kind of like also should be able to verify the identity of the seller, the buyer, also verify the ticket serial number, so just to make certain that it is valid, that it's a ticket that, I don't know, you're trying to sell a ticket of an event that already occurred, it could happen, and also to be allow the system itself to audit the platform. Now, with that being said, if we can like design everything on this system, we could have a diagram, something like this. It's a little bit complex. So what I'm going to do here is just kind of like go through like the different steps with a small animation, and hopefully that will make show you a little bit how things can work. So we already kind of talked about these two actors, the seller, the buyer. So no surprise there. But the thing is that to have our TicketSquire, we're going to have also other parts of the system working correctly. So really quick, we're going to have two smart contracts. The first one makes sense. That is the NFT. That's the one that is going to represent the actual ticket. Then we're going to have a proxy contract that I'm going to explain in a second what it is. That's something like how Midnight works. Then the ticket marketplace. That's the system that we're working on. And finally, an identity platform that really, I put it on the seller side of things, but pretty much can work also for the buyer. So like the buyer itself at some point will have to identify themselves. And if you think about other types of system, this is also something that works really well because this identity platform could work for things like verifying if someone is, well, an adult, so over 18. There are several restrictions of what you can buy, you cannot buy, what you can have access to, depending on that. Now, first step, we're going to, well, the seller is going to deploy an NFT contract. Like I said, that is going to be the representation for the ticket. After that, the seller is going to make a request to the marketplace and just say like, okay, well, we want to import this smart contract, like check it out. Then the ticket marketplace will have to ask the seller like, hey, let's check if you are eligible to sell the ticket. And at that point, the seller would have to kind of like connect with the identity platform to be able to say like, yes, let's create the proof that I'm eligible. So like I'm the person that I say that I am, I live where I say that I live, I'm a grown-up and I can sell that. And then that proof is what is going to be sent back to the marketplace, to the ticket marketplace. After that, the ticket marketplace take that proof, verifies, yeah, it looks like it is good or not. Obviously, if it's not eligible, pretty much the process ends there. But if it is, then it's going to, the ticket marketplace create this proxy smart contract that we just created here. So how Midnight works, like these two contracts, the NFT and the proxy ones, they are going to have like their own privacy space. So we don't want them to kind of like just share information willy-nilly. So why is it that the ticket marketplace wants to create this proxy smart contract? It's pretty much to augment the capabilities that you're going to have with the NFT contract. The NFT contract, like I said, it is just kind of like a representation of the ticket. But now with the proxy, we're going to see it in a second, we are also going to add things like charging a fee, which is important for the ticket marketplace because that's where they're going to get their business, you know? Like it's going to say like, hey, when you're going to sell this ticket, well, I'm going to have a fee of $1, let's say. So then that is done through the proxy contract. Then the buyer is going to kind of like say, I want to buy. That, of course, that could happen 3 days later, a month later, whenever that is. Then the proxy contract is going to do the same thing, like show me that you are eligible to buy that. Again, there could be restrictions. The buyer is going to do the same process that the seller had, that was to generate the proof and send that back. Now the proxy contract is going to verify that proof, and then is going to, in this case, apply the fee. At that point, then the NFT contract can say like, yeah, you can buy this ticket, and it's going to recheck that it's authorized, it's going to record that transaction, and then is going to send the proof of the transaction first to the proxy contract, that is going to, again, verify it. And as you can see, there are like a lot of verifications in almost in every step just to make certain that everything is working correctly. And then finally is going to send to the buyer the confirmation message that says like, you got the ticket to do, I don't know, UFC, Taylor Swift, F1, whatever it is that you are interested in. Finally, the buyer retrieves the NFT, and now they are the happy, hopefully, owners of a ticket for an event, whatever is that event. And that is pretty much it here on this part. Now, I'm going to jump to my browser, and we're going to do something a little bit different. I'll have to go all the way up here, because I already did this in the session earlier in the morning. So this second part is going to be a little bit different because I'm going to be showing you several websites that are going to be useful for you. And then I'm going to kind of like do a couple of things on Visual Studio Code. So hopefully that works, which quite likely I should have done that before, man. Okay. So give me 1 second. I'm going to destroy the folder here. I did this entire process in the morning, so I should have done this earlier. And where's the thing? This one. Okay. Where is it that I am right now? Okay, that's good. And this one, okay, clear. So I'm just going to kind of like have it ready for this part. So what I wanted to do with this part is pretty much almost a small workshop with all the steps for you to kind of follow and set up your environment to start developing. And after that, at the end, we're going to create a really quick smart contract that you can follow there. Now, since this takes a little bit of time, especially downloading, and I don't want to kind of like for you to rely on the hotel's internet, what I'm going to do is just to show you the QR code. Here you can have access to the Google Doc that has all the 13 pages of all the steps of the workshop. So I'll leave it there for a second. And then if you're interested, obviously you can follow this at home and just make certain that you can create on your own like the smart contract. But since I don't want to keep you here for too long, especially going through all the steps, I'm just going to explain how to get that, especially the environment setup, and then we're going to create our small contract. So I'm going to give it a second. Yeah, thank you. So, and this is also why I have kind of like this screen here, to be able to follow like at the same time that some of the steps and I don't forget anything. Also, a couple of weeks ago, we did have a similar presentation by our CTO. So he got into a lot of the details of what is Midnight, how Midnight can be used, and they had like really good questions from the audience during that. So if you have not checked our YouTube channel, I would recommend you to go to check this video. It is really good, so just go in that. Now, that being said, first page makes sense, midnight.network, simplest place for you to find links to all the documentation, all the developer information that you're going to find there. If you go to the top, developers, you're going to have the developer hub where you will find all the information about hackathons, upcoming events like this one, and then the link to the documentation that we're going to check in a second. That documentation, one of the important parts here is the quick start that allows you to, if you have some of the things installed already, to really get into the right place. And one of the things that we're going to check there is the releases page. That shows you what you need to have in your computer to be able to run a Midnight app. First thing, the compiler. That's what we're going to use with Compact. It's called Compact C, and we're going to use it to compile our smart contracts. Examples, you don't need to download it, but obviously, like, it's useful if you have it. Visual Studio extension, you also don't need it, but as we're going to see with the example, it's useful. The wallet is completely needed, the same thing as the Docker image for the proof server. So we're going to see like how that works. So now, for each one of them, the compiler, pretty much you do have to just download the right version and then install it. You just kind of like follow the steps that you have here and the instructions. Well, this is for the proof server, so I'll kind of like check there. And The proof server, it is a Docker image. So if you don't have Docker in your computer, you will have to install it. Personally, I do like to use, and I'm going to do it right now, which I have to go to the images. I like to use Docker Desktop to be able to easily just kind of like pick the right image and say run, which is really useful. And after you have that ready, you can go to your terminal or command if it's, I don't know, Windows, and this is kind of like the instruction that you're going to run. Of course, this is something that I'm not going to remember all the details, so like you do have, and you can copy paste it directly from the instructions that you have in the workshop. So it's really this one that is just kind of like run that image. So let me do that, and hopefully that works. Okay, not a problem. So we're down there. After you have, I'm going to check really quick here on Visual Studio Code. So this is one of these things that if you want to do it, that's fine. We have a VSI file that you can just go here to the extensions tab and install from BSIX and pick the file that you have there, or what I usually end up kind of doing most of the time is just drag and drop and then installs the extension. Here, this is kind of like the contract that we're going to write at the end. As you can see, the extension allows you to have obviously like a color coding, like the code, and also gives you some autocomplete, which is quite useful, especially when we're kind of like going to run this thing. Now, one of the last steps that we have to kind of like do is to install the wallet extension. That is also going to be an extension file that you can install in your browser, Chrome or something like Brave too. Usually you have to kind of like go to extensions, manage extensions, and from there you're going to pick the file that is going to load an extension, or in my case I'm not going to do it because I already have it installed, but this is how it should look and how you can expand that view. So keep an eye here of the dust or the T-dust that I already have in my wallet, because the next step that you're going to have is to go to the faucet that I should have. Where do I have it open? Oh, I already have this one open, man. Where's my faucet? I closed it? Oh, okay. I want the link for the faucet. There you go. So right now we're on DevNet, soon to be on testnet. So while we're in DevNet, in testnet 2, we're going to have a different. You are going to be able to request TDust for all the transactions that you are going to do on your testing and development. In this particular case, you can go to the extension, to the wallet. You could say, I'm going to received. You can copy your address. I think I did it. Go back to the faucet, paste it, and just request the token. So since this is the first transaction and it's kind of like a test one, just to make certain that you have the dust and that everything is installed, one of the things that I like to mention is that most of the errors that we see when people are testing and say like, this is not working, is that they are not running their proof server. Not every single transaction, you have to kind of like have the proof server running, but that happens with many transactions. In this case, well, we don't really need it here, but we already kind of like say that the transaction run successfully. And if I go back to my, now. So it went from 23.99 to 28.99. So it gave you 5 TDust that it should last you for, I don't know, a week unless you are doing heavy testing. Almost every transaction costs right now around 0.1. So 5 TDust should kind of like last you for quite some time. So at this point, we kind of like almost know for sure that things are working. The only one that I may be missing is some of the setup that I'm not going to go through the detail on setting up the compiler, Compact C. You can see that you may have to do run a couple of instructions just to make certain that you have the right environment path and that everything is working correctly. At the end of the day, you want to kind of like come to this instruction, Compact C version. that we can check on our terminal. I'm going to go here. And if things didn't get installed correctly, then you're going to get an error. In this particular case, obviously, it shows me the version of Compact C. So at this point, we're pretty much good to go. So just to kind of like get into the coding part of everything. So after installing the extension, you can say, well, I'm going to just kind of create it here. Directly create a folder for your project. Then cd my project. And yeah, no, that's it. You could create the file directly in that folder, but I'm going to do it directly from Visual Studio Code. So I want it to be hello-world.compact. So new file, this file, Word compact. It's going to ask me, obviously, where do I want to kind of like put it, and I already created a folder named my project. So sure, create a file there. At that point, the first thing that we should do is to include the library. So it should be, let me see, kind of going to the code, so just to make certain that I'm not going to miss anything. So we're going to include std, and here this. After that, pretty much your contract is going to have like two main parts. That is going to be the ledger, so everything that you want to kind of put in the ledger, and everything outside of that. So we're going to start with ledger, and this is where the Visual Studio Code extension helps. If you press Control space, you're going to have kind of like this autocomplete. In this particular case, I'm going to be looking for ledger, and I know that is this one. And then it already kind of gives you the little template of what is the shape that you are going to have in the ledger. This is a hello world, so I'm literally going to change the name of that variable name X to message. That is where we're going to want to have it, so message. And this is going to be a cell. So I'm going to explain really quick about cell and a couple of other things that, restricted names that we're going to have here. And the first one is the cell that is going to be a cell whose value is going to be updated by circuits. So that is what we have here in the message. Now, like the type that I want to make this is maybe opaque string. What is that? So the type of maybe describes something that may have a value or may not. So in other languages would be kind of like a null value or not. So we're going to say cell. This one is going to be maybe. And then inside of that is going to be opaque. Opaque. And what that means is that in this particular case, for message, we don't really care about the internal structure of this variable, of this cell in this particular case. So that means that message could be anything, and the circuits, like the contract, doesn't really care what it is. In this particular case, we do know what it is. That is going to be a string. Okay, perfect. So we have our message. Now, when you have a variable like this or a cell, we need a constructor. So again, Control space, constructor. And I know that is this one. And it should be similar to what we have with the ledger and even the message, that it gives us a template for this particular function. And in this particular case, what we need to do, you are going to have already field, although in this case I'm going to eliminate it, that is going to be what are going to be the parameters for this function. In this case, we don't want anything for the constructor. I'm just going to say like, well, I just want to initialize the message. So I'm going to say that the ledger.message equals, and then we're going to have none. That is almost like the null in other languages. So we're going to have an empty string. And again, this is going to be opaque. And this is going to be of the type string. Okay, I think, and this is a function, so then it should be, yeah, like that. Okay, perfect. So with that, we're just kind of saying we are going to create at the very beginning an empty message. That's pretty much what it kind of comes down to. Now, outside of the ledger, we're going to have our circuits. So I'm just going to do the same thing autocomplete, and I'm going to say circuit. Okay, there. And then this is going to be exported. Again, it's going to tell me in this particular case it's going to be foo, the name of this circuit. Of course, I don't want it to be named foo. We're going to get the parameters, and we're going to get the type that is going to be returning at the end. So in this particular case, what we need to do is going to change this foo for update message. Oh, update message. We are going to receive, instead of X, I'm going to call it, to make it clear, a new message. And this is going to be an opaque string. So opaque, opaque. And this is going to be a string. And we are not going to return anything here. We're just going to modify the message that we had there. So I'm just going to say that is void. So I'm not going to, I'm going to eliminate this return. We don't have like any return here. But what I'm going to do is that I know that is the ledger.message equals sum. This one is going to be opaque, string, to, string, and like the 2, and then this is going to be new message. So pretty much the parameter that we receive that is called new message, we're assigning it to the message that we have in the ledger. Now, one thing that I'm going to do here, and this is really good in terms of order, is that in Compact you can also create your own types. Usually you can do that with enums. So I can go out here and say enum. And in this particular case, I'm just going to call it state. Why am I going to create that state? Because I want to kind of like have something that, that helps me to keep track of the state of the message. So I want to be able to kind of like know at any given time if the message was initialized or not, if it's empty, or we already kind of like assign some state there. So what I'm going to do for this specific set is I'm going to give it like two options. That is going to be unset and set. So pretty much you already set the message or the message is set. Simple as that. Now that we have that enum, I can create another cell that is not going to be the message, but is going to be called a state. So in this, you see the difference, capital state, that was the type, and then this is going to be the name of the variable. And this is going to be, no, there. This is going to be a state, and, no, a cell state. So I have to say first cell, then, and the type of, oh, small pop there. This is going to be a state. And that's it. Now, we already kind of like initialized the message here in the constructor, but we have not done the same thing for the state. So let's do something similar. So ledger.state, state, oh, damn it. State, and then this equals state. And at the very beginning, we're going to say that this is unset. So we know that at the very beginning, the message has not been set, and we have to do something about that. Now, we already have the, and then we also modified the update message here. Since we're already updating the message, we should say at this point that the ledger.state is going to be state set. Perfect. So that's how we have it. Now, just to kind of like do the last part of the code that, as you can see, is not really kind of like a lot, but well, it's a live thing. We're going to create another circuit that is not going to be updating the message. We already have that one. It's going to be to read the message. So I still can say circuit Then again, we have the template here, so I'm not going to say that is food. This is going to be called read message. We don't receive any parameters. No, that's not going to be good here. And what we're going to say, or we have to say, is what is going to be returning. So this is going to be an opaque string. Okay, perfect. Now, here, this is something that is a little bit different from other languages, and is an assert. In most languages, they assert most of the time. You kind of like do it on debugging, and then that's something that when you kind of like go to production is going to eliminate those asserts. They are not going to appear here. And compact is pretty much used to kind of like be able to, well, check the state of something. In this particular case, is the state, where I'm going to figure out what is the state of the ledger state. So, and I'm going to ask here if this is the same as state dot onset. Okay, perfect. And if this happens, then I'm going to return the value. The message is empty. Well, the message, not re-message, the message. Perfect. And now, if that doesn't obviously, if that's what happens, it immediately is going to return that string. There is the message is empty. If not, then it's going to return whatever I kind of like add here. That is going to be the ledger.message. And then we need the value. That is the one that is the string that is going to be there. Okay. Fine. Now, when you're done with that part, the next step that you have to kind of like do is going to be, and well, you guys can see that almost 6 pages in the workshop are just kind of like this step-by-step of the lines that we just kind of like wrote. The last part that you have to do is to run this instruction that is run compact C. In this particular case, well, the command is that compact CSH, and we have to provide the name of the compact file for the contract, that in this case is hello world compact, and the full path for that file. So I'm going to do that. I'm going to share here. And of course, there is something. Let me see if I can figure out really quick. If not, then I'm going to cheat, and that's why I had another copy of the entire code, because I knew that something like this, going line by line, could happen. So let's go. Line 17. Where are you? Line 17. What am I missing here? I'm sorry? Equals. Oh, okay. Well, there you go. You guys were paying attention. Thank you. That's good. I was going to go.
Line 11. Yeah, SG string.
Oh, awesome. Okay, you guys were really paying attention. Thank you. Like, and I'm bad at typing, so well, obviously this kind of works there. So let's try it again. Let's see. It seems that it's doing something, and I think it's going to get it. Perfect. So the result that you're going to get here is always kind of like an error or this type of message. In this particular case, what we kind of like see is that we have 2 circuits, so that are update message and read message, and then it begins to tell you circuit by circuit what is the complexity of each one of them out of all the constraints that you're going to have here. So in this particular case, we're kind of like ready to go. So that's pretty much it. So we don't have to kind of like do more. Oh well, kind of like Sam kind of like came also at the end. So I'm kind of like done. I'm going to just kind of go back to, and I had it here, this slide, and then pause really for any questions that you may have. I think the last thing that I just kind of like want to share is that we are obviously creating new things in terms of like documentation, templates, examples. So we are going to see more of that in the next few weeks. I would recommend you not only to check the documentation and check the night paper like Mauricio mentioned before, but also to go to Discord and join the community. That's kind of like the perfect place for you to guys ask questions. You know, if you have an error or something like that, if it's not me, it's going to be someone in my team or someone also in the community, marketing and engineering. They are trying to kind of pay attention to the different questions that we have in the different channels. And if you are already creating any kind of like projects or are interested in doing that, that's also kind of like the perfect way to showcase what you're doing. So I'm going to stop there and see if you guys have any questions. Yeah, please. We had a microphone over here. Yeah. Yes, so everyone can hear you.
So, hello.
Hi.
It's quite obvious to me that the smart contract is not a UTXO model-based smart contract system.
Uh-huh.
So does that mean like substrate sidechains are not, like, can it be UTXO model, or is it basically set to be account model?
It can be. So
Okay.
pretty much you as a developer, you can decide like how you want to set it up and like go one way or the other. Yep. Perfect. Perfect.
Not much, actually. What's the relationship between Cardano L1 and Midnight? So go back to the e-commerce case, the buyer-seller NFTs.
Uh-huh.
Is this the same NFT that we are kind of used to, like native token living in the Cardano blockchain?
No.
Okay.
So right now, pretty much the entire thing about Midnight being a partner chain is not that we're kind of like really on top of Cardano. Like we really have our own technology. We do take the benefits of the partner chain technology. So especially for the node producers and the SPOs, then you're going to be able to have almost the same setup, or at least the very beginning. But we're kind of like our own chain. So like we are going to have our own implementation for the NFTs, and it's not going to be the same one as that you have in Cardano.
I see. Okay. Then, is there a roadmap where there's some kind of messaging layer between, for example, if I have an asset, I need to spawn the same asset, a representative on Midnight?
Yeah, so right now that's something that we're kind of like working with a few partners to kind of like have that ready. Well, I don't know exactly when, but so you could kind of like do the same thing. And then obviously we do know that the Cardano developers are going to be some of the first ones to start adopting Midnight. So we are going to maintain that relationship and try to make it as easy as possible for you to kind of like have that relationship there. So whenever it makes sense.
So it seems like from now, currently what you have here is like more the infrastructure side of things, the very protocol of smart contracts, the transactions. So to reach a point of making that marketplace for real, like where there's a front end, people can connect wallet and put up some assets, obviously a Midnight protocol asset. What's the gap from a tooling perspective that we can be involved in? Like how far, what are the things that's missing to reach that stage?
That is kind of like in the roadmap right now. Like with the focus has been kind of like in the just Visual Studio Code, kind of like have the extensions, but we are going to provide like all the other tools that you're going to need for your development. So that's also going to be there, so without a problem. But since we do want to kind of like get the feedback and create and spend our time and prioritize on the right places, I would actually ask you to kind of give us a little bit of feedback on what is it that you really need, so we kind of like start or working with partners to create that, or creating all the tools ourselves.
So is there grants, since you are here, grants for adopting use case for projects, and also grants for building tools, which is like compact and all this? Yeah.
Right now, through the partnerships team, that is kind of like the easiest way that we have to kind of like provide like those incentives. But we're going to publish soon kind of like the full kind of program on terms of grants and bounties, because we want to kind of like also help people, like if you find any kind of error, or if you just have a project that you want to work on, then just kind of like let us know what is it that you want. But yeah, like that's in progress. And we have had that question for months now, like, hey, do you have any grants or something like that. Right now it has been a little bit more almost like a one-on-one partnership type of thing, but we want to make it available for all developers. Okay. Well, I think that's pretty much it. I sincerely thank you for coming. If you guys are going back to the conference center, like if you're going to go back there, like I would encourage you to go to our booth if you have not been there. I see that some of you already have like the midnight shirt, so I know that some of you have already gone there. But please, by all means, like go and talk with the rest of the team, and let's see how it goes. And thank you very much. No, thank you.